Okay, we're going to do a quick factoring review before we start the lesson for today. The first one we're going to factor is a trinomial in the form ax squared plus bx plus c, the standard form of a polynomial, where a, b, and c are the coefficients, c is a constant term, and a in this type of problem equals 1. When a equals 1, all you have to do is use the big X. We call it the big X method. So the first step is use the big X. And that means you want to take factors of a times c that add to b. So a times c, since a is 1, is just 8. So in this case, you would just use c. If this is just 1, it's just the factors of a times c, the product of a times c is just 8. b is your the coefficient of your linear term, which is 6. So we need two numbers that multiply to equal 8, and when I add those same two numbers, they have to equal 6. Well, the only factors of 8 are 1 and 8 and 2 and 4, so of course we're going to use 2 and 4 for that. Okay, so now that we have our two factors, you're just going to plug the factors, these two numbers, into binomials. So plug the numbers that fit step 1 into two binomials. Remember, these two binomials that we're looking for are going to multiply together to equal x squared plus 6x plus 8. So I make my two sets of parentheses. I put an x in the beginning, or whatever your variable is. In this case, it's x. And these are both positive numbers, so you just put plus 2 and plus 4. And that would be your final answer. Now, remember the definition of factors are things that multiply together to equal something else. So when I multiply these using FOIL or box method, I would end up equaling this. That's how you can check your answers when you factor things. Okay, go ahead and pause if you need to catch up. And the second type of problem we're going to look at is a trinomial, but now I have a different number other than 1 in front of my first term. So we're still using ax squared plus bx plus c, but now a does not equal 1. So the first thing you want to do when you get a trinomial where a does not equal 1 is look for a GCF. Some of you might have already thought of that, the greatest common factor. It's a greatest common factor only if a number is expression is a greatest common factor only if it's a factor of all three or every term of your polynomial. So the easiest way is to look at your first term and look and see if that number is a factor of the other terms. Well, 2 is a factor of 4 and it's a factor of 30. So the second thing you would do is divide. Let's use a second color here. Divide by your GCF. So in other words, you're factoring out that GCF. So I'm going to divide all of these by 2. And when I rewrite the expression, so in rewrite expression, so I rewrite the expression as 2 parentheses and then divide. So 2x squared divided by 2 is x squared, negative 4x divided by 2 is negative 2x, and negative 30 divided by 2 is negative 15. Okay, now you can just follow the steps from part 1, from example 1. So now you use the big X. So follow example 1. So I use the big X. So now my coefficient is 1. The 2 is not part of this expression anymore. It's factored out. So my a is 1, c is negative 15. So I use negative 15, factors of negative 15 that add up to negative 2. And those two numbers could either be 1 and 15 or 3 and 5. Well, since they have to have a difference of -2, it's going to have to be 3 and 5. And the 5 will have to be negative, because when I add them, I have to get -2. So now I write my two binomials, and it's x plus 3, x minus 5. But I still need to put the 2 in front, because that's also a factor of this original polynomial, meaning if I multiply the 2 times x plus 3 times x minus 5, it will equal 2x squared minus 4x minus 30. The third example is also in the form ax squared plus bx plus c, and a does not equal 1. However, now I do not have a GCF. So we're going to use the airplane that some of you learned in Math 2. So what that means is you're still going to multiply a times c. Okay, so we're going to we're going to multiply a times c. So I have 2 times -4, and that number goes up here. So it'll be -8. And we're still looking for numbers that add up to b, -7. That goes on top. Multiply a times c, and that goes on top. Put b on bottom. So we're looking for factors of -8 that add up to -7. So that's going to be -8 and 1. And then you write out using this number in front of the x. So write out your binomials. With a in front of x. So I'm going to write 2x for the first part of my binomials, because my a is 2. If it was 3, you'd use 3. And then I'm going to put -8 and +1. The last step, divide by a if possible. And that means both parts of your binomial have to be divisible by a. Since a is 2, I can divide this one by 2, and I can divide this one by 2. But in this binomial, I cannot divide 1 by 2. So I don't divide anything into this binomial. I do divide this one. So my final answer is going to be x minus 4 and 2x plus 1. The last one we're going to look at today is a difference of squares. And we write that as x squared minus, sometimes we use a different number, we're going to use c squared for this. X squared minus c squared. It's a difference because we have a minus here. It's always two terms, and both terms have to be perfect squares. If both terms are perfect squares, you square root both terms. So a squared equals, the first term is x squared, so square root of x squared is x. And then don't worry about the minus sign, just take the square root of the 25, and that's 5. So this is my x, this is my c. So I'm going to rewrite the expression in the form of two factors. They're going to look like x minus c and x plus c. So I'll write my two binomials. X comes first, or whatever this square root of this term is, goes first, and the square root of this term goes second. 5, 5. Then I make 1 plus, 1 minus. It doesn't matter what order, you could do minus plus because it's multiplication and that's commutative. And that's true for all of these factors. If you put the negative, if you put the 1 here and the -8 here, you'd just be dividing this one by 2. You'd still get the same two factors. And for this previous one, same thing. You could switch these two, plus 3 and -5, and when you multiply that out, you would still get the same answer. So I want you to stop the video, and I want you to try these 4 problems, which are exactly like the 4 problems we just did. You should have been taking notes during that time so that you can use those to refer to as you do these problems. And then I will show you the solutions after you do that. Okay, so you should have completed all 4 of these problems, and I'm going to just show you the solutions. Here's numbers 1 and 2. And then we've got 3 and 4. Okay. Now we're going to talk about, yesterday you learned how to do synthetic division. Now we're going to do something with a synthetic division. So we're going to go to the guided notes. In your guided notes, you're going to go to this part where it says synthetic division and the remainder theorem. Is 5 a factor of 20, and how do you know? So it's on the bottom left of the front of the notes. Okay, so we talk about factors. Factors are numbers that are letters, or a combination of numbers and letters that multiply to equal something else. So to find the factors of something, we figure out, okay, if 5 times something equals 20, then 5 is a factor. Or we can say 20 is divisible by 5 because that equals 4. Either way, we know it's a factor of 20. And it's when I divide 20 by 5, it equals 4, and there's no remainder. But if I divide 20 by 3, there is a remainder, right? We subtract and we get a remainder of 2. So we say this is 6 and 2/3. So since there's a remainder, 3 is not a factor of 20. But is x minus 3 a factor of 2x squared plus 5x minus 15? How do I know? Well, I could factor it using the big X. If I do that, factors of -15 that add up to 2, I think we might have done this one earlier, you get x minus 3, x plus 5. Well, yes, x minus 3 is in fact a factor of that polynomial. Is there another way I could figure that out? Well, that's what we use the remainder theorem for. If I divide, so we're going to the top right now, when you divide x squared plus 2x minus 15 by x minus 3, what is the remainder? That should say x minus 3 there. In these notes, some of the things did not print. So you're dividing by x minus 3. When I do that, well, in the box, I'm going to put 3, because I want the opposite of this number. And then my coefficients are, it's a quadratic with 3 terms, and I have all my terms, so I don't need any zeros. So I use 1, 2, and -15. And then bring down the first coefficient, multiply by 3. I get 5. 5 times 3 is 15. And my remainder is 0. So when I write this out, I'm going to write x plus 5. That's what you get when you divide x squared plus 2x minus 15 by x minus 3. And the remainder, notice, is 0. So if we go back to what we were talking about when we were dividing 20 by 5 and we get 4 with a remainder of 0, well, if the remainder is 0, then I know that 4 is a factor, because if I know that the remainder is not 0, we know that 3 is not a factor. It works the same way with polynomials. If there's no remainder, then that binomial that you divided by is a factor of the polynomial. So that means x minus 3 is a factor, of x squared plus 2x minus 15, since my remainder, I'm just going to use an R to stand for remainder, is 0 when I divide. Is x minus 2 a factor of x cubed plus 4x squared minus 11x minus 30? So remember, if it is a factor, my remainder will be 0. So all I need to do is use synthetic division. I have 3, 2, 1, 0 for my powers, so I don't need any zeros for coefficients. 1, 4, negative 11, negative 30. Bring down the first one, and it's a 1. And then I multiply around, add down. So 1 times 2 is 2. 4 plus 2 is 6. 6 times 2 is 12. Negative 11 plus 12 is 1. And 1 times 2 is 2. Negative 30 plus 2 is negative 28. So this is my remainder. So what would be the answer to this question? Is x minus 2 a factor of this polynomial? The answer is no. The remainder, that's going to be in my abbreviation, does not equal 0. So it's not a factor. X minus 2 is not a factor of that polynomial. So you can try this one, pause, try this problem, and then bring it back on after you've tried the problem. You're going to have negative 4, not negative 4. You're going to have positive 4 in the box. 1, negative 4, negative 20, 24, because I don't need any zeros. 3, 2, 1, 0. I have my consecutive terms. So it's not a factor since the remainder does not equal 0. X minus 4 is not a factor of that polynomial. Okay, so what are some other ways I can use this fact that when the remainder is 0, I know that something is a factor of your polynomial? Well, let's try completely factoring a polynomial. Can I factor a polynomial other than a quadratic using this idea? Let's use the polynomial x cubed plus 5x squared minus 12x minus 36 divided by x minus 3. And see if we can do this. So the first thing you would do is divide, right? Which we learned yesterday. So if I divide by x minus 3, and I get a remainder of 0, I know that x minus 3 is one of the factors, at least, of this polynomial. So let's do this. I put a 3 here. 1, 5, negative 12, negative 36, and divide. And my remainder is 0, so that means x minus 3 is a factor. Okay, so if I know x minus 3 is a factor, I know that since this is going to be x squared plus 8x plus 12, I know that if I multiply x minus 3 times x squared plus 8x plus 12, it would equal, so this times this should equal my original polynomial if I multiplied that out. But what if I want to find out if there's any more factors of this polynomial? Well, could I factor this trinomial? Let's see, if I don't have a leading coefficient, well, the leading coefficient is 1, so I could just use the big X. Factors of 12 that add up to 8, and I think 6 and 2 would work. So I know also x plus 6 and x plus 2 are factors of this polynomial, so that means they're factors of the original one, because now I know that this times this equals this, and I already knew that this times this equaled the polynomial, so by what we call the transitive property, these two times this one have to equal the original one. So x minus 3 times x plus 6 times x plus 2, if I multiplied those out, would equal this polynomial. So if the remainder is 0, then factor this quotient, the answer that you got, with the synthetic division. So the answer from synthetic division is 0. Factor what that answer was, which was this thing here. We factored this, and we got our final answer, which was this. Okay, so do these. If I divide this polynomial by this and I get a 0 remainder, then I know that it's a factor and I can factor that answer. So let's put my -5, 1, 3, -13, -15. Bring down your 1, get -5. 15. So I get a remainder of 0, which tells me this thing, x plus 5, is a factor. So one of the factors, so far I have one factor. So far I know that x plus 5 is a factor. But if I factor this, which would be x squared minus 2x minus 3, if I can factor this, then I know I have two more factors. So let's see, factors of -3, that equals -2. It's mean -3 times 1, so x minus 3, x plus 1. So my other two factors are x minus 3 and x plus 1. Okay, so if you want to stop the video and try number 2, and then come back on and I'll put the solution up here for you. So the answer to number 2 should be x plus 3, x plus 4, and x minus 3. The last way we use the remainder theorem, which just says if you divide, well, first of all, if you divide a polynomial by a binomial and the remainder is 0, then that binomial is a factor of the polynomial. If I divide any polynomial, p of x, so p of x could be any of the functions we've looked at so far, by this binomial x minus a, which we've been talking about, then that remainder is the value of your function when x is equal to this number a. So in other words, if I said, if I take x squared plus 3x plus 2 divided by x plus 1, that means a is -1, right? So if I evaluate, that means x is -1. What we're saying is x is -1. So I'm using f of -1. So I'm going to plug -1 into this function. So -1 squared plus 3 times -1 plus 2. 1 minus 3 is -2 plus 2 is 0. So basically what this is saying is the value of the function when x equals this number a is the remainder when I divide. And I'm going to show you what that means. It'll make a little more sense to you. So we're not going to use the polynomial I have on here. I'm going to use a simpler one. We're going to use 3x squared minus 20x plus 12, and we're going to evaluate for p of 3 still. So you're going to take 3, because a is 3 in this one, and put it in the box. And I don't need to put any zeros in, so I have 3, -20, and 12. So you're going to divide using synthetic division, and you're just going to place whatever this number is here in the box. Don't change the sign. Don't flip the sign. So whatever this number is, that's the number that goes in the box. And use synthetic division. -11 times 3 is -33. So this is -21. So p of 3 means the value of the function p of x when x is 3. And the value of p of 3 is the remainder. So in this case, the remainder is negative 21. So the value of p of 3 equals negative 21. Well, let's just check that. Put 3 times 3 squared, if I substitute the 3 from x in my function, minus 20 times 3 plus 12. If you put that in your calculator, you should get negative 21. You're going to go to example 4 in your book. Oh, let's just do this one because I didn't even tell you to get your books out. So let's just do this problem here, and then I'll tell you what I want you to do for your assignment. So I want to evaluate this function when a equals 2. We also call this synthetic substitution. And this is nice because you don't have to plug a bunch of numbers in your calculator. Synthetic division is quick, it's easy, so if you have a long polynomial like this and you want to know what the value of this polynomial is when x, I don't know why they put an a here, when x is 2, then you just plug, instead of putting it in your calculator, you can just put 2 in the box, put 3, negative 4, negative 5, and 1. You can time it and see which takes longer, but I think this is probably quicker if you're good at it. So the value of this function is this remainder, negative 1.